Today, we are diving into the world of nozzles for the Sovol SV08 and T300, both of which use the same type. We'll explore nozzle sizes ranging from 0.2 to 0.8 millimeters, fine-tune our Orca slicer settings and printer CFG files to accommodate them, and put everything to rigorous test. And of course, I'll be testing PETG with the new nozzles, printing the customary dust covers I designed, this time for my new printer, the AnyCubic Kobra 3 from geekbuying.com, and even my 3D scanner will make an important appearance in this video, so strap in. This will be quite an adventure. For those of you who are new here, I am Gergo, and welcome to Gergo Print 3D, my YouTube channel about our adventures in 3D printing and laser cutting. As always, chapter markers and translation-ready subtitles are at your disposal. Our community has been grappling with the infamous PETG issue for the SV08. I even dedicated a video to addressing this conundrum. Sovol responded quickly and thoroughly, and now I have the upgraded nozzles in hand. One key improvement is that the new press-fit nozzles won't come apart, thanks to a grub screw that holds the nozzle securely in place. The lower hole is for the thermistor, but the slightly larger threaded hole holds the grub screw. You would need a metric size 1 Allen key to adjust it, though there is really no need to touch it during normal use. Its purpose is to prevent the nozzle from being pushed out under the increased pressure when printing PETG, for example. As you can see, I've received several sizes of this upgraded nozzle. We'll test the 0.8mm variant in the SV08 and the 0.2mm nozzle in the T300. I also received a pair of alternative nozzles that return to the threaded design used by the SV06 Plus, 7, 7 Plus, and T500, or so I thought. Initially, I was excited to see these hardened steel nozzles, which looked identical to those earlier ones at first glance. However, closer inspection revealed some differences that will require more testing to confirm compatibility. If you're interested in a follow-up on these hardened steel variants, let me know in the comments below. Now, let's kick things off with the 0.8mm nozzle, which we'll install in the SV08. With this larger nozzle, we can print the dust covers I designed for my 3D scanned new printer. In the next chapter, we'll tackle disassembling the Combo T300's extruder as well to print high detail models like this tiny cute 3D benchy. If you don't already have this extruder cover guard, check out my earlier video on some recommended easy upgrades. We could remove the silicone sock later, but why not start with it now? It's good to have this on film because we will need to unplug most of the wires here, and this footage will come in handy to reconnect everything properly. Thermistor, inductive probe, a little isopropyl alcohol helps remove the glue. Let's remember to reapply some glue during reassembly. Nozzle heater, extruder cables. Now we can access the two M3x16 screws holding the hot end from the left side. There's also a third longer M2.5x30 screw securing it from the front. We'll need to cut the two zip ties bundling the wires together. Start with the first batch and unplug the extruder fan along the way. And be very careful when cutting the zip ties to avoid damaging the delicate wires. For comparison, let's also remove the T300 Hotend. The process is very similar, but here the extruder cover has an integrated two-head LED light that needs to be unplugged. The silicone sock is identical to the one on the SV08. On the T300, only two screws secure the hot end, and they are accessible from the right side. The M12 inductive probe is attached to the heatsink. And while it's not strictly necessary to remove it, doing so makes things easier later. We only need to unplug the thermistor, the extruder fan, and the heater wires here. I'm not sure why I unplugged the part cooling fan as well. It wasn't necessary. Here are the two hot ends side by side. Notice they look different. The SV08 hot end has a larger heatsink, and although the extruder fans are identical, they are secured differently. We'll discover more differences as we replace the nozzles. And let's start with the T300 Hotend. After nearly a year of use, I had trouble removing one of the screws securing the nozzle to the heatsink. Before applying more force, I carefully slid off the clamp holding the sensitive thermistor and heating element to the nozzle. It's not on film, but eventually a pair of pliers helped loosen the screw. Even then, the nozzle wouldn't budge. I'm glad I didn't force it though, because I found two tiny grub screws behind the extruder fan. Loosening those freed the nozzle. Now let's see how it goes with the SV08. This time I started by removing that extruder fan, but there are no grub screws behind it here. So remember, in case of the SV08, if you want, you can leave the fan attached. Next, I removed the screws holding the nozzle, and it slid out easily. I noticed they used some thermal paste here. After sliding off the clamp, I carefully removed the heating element and the thermistor. Sovol was much more generous with the thermal paste in this setup. Installing the 0.8mm nozzle is the reverse process. First, apply thermal paste to the nozzle stem, then align the nozzle correctly. The indentation for the heating element should face the side with the heatsink's cable channel, while the thermistor hole faces upward. I also applied thermal paste to the underside of the heating element and dipped the tip of the thermistor into it. Besides improving thermal conductivity, the paste also helps keep both in place as the clamp slides back on, with its gap going directly over the heating element. And be careful not to damage the thermistor wire. Reattach the fan if you removed it, slide on the silicone sock, aligning the smaller square cutout on it to make space for the wires. Before installing the assembled hot end into the SV08, let's move over to the T300. We secured the 0.2mm nozzle here with its two screws, ensuring the thermistor hole is on the opposite side of where the fan will go. Don't forget to tighten the grub screws there before reattaching the fan. Then install the heating element, thermistor, clamp, and silicone sock the same way as we did with the SV08. If using an electric screwdriver, set it to a low torque to avoid over-tightening. Reconnect all the wires in the following order: heater and thermistor first, then the part cooling fan and extruder fan. If you removed it, reattach the inductive probe using its two screws and plug it into the tool head board as well. Finish by plugging in the tool head light wire and securing the cover back on. Back at the SV08, we start with the long M2.5x30 screw from the front, followed by the two M3x16 screws on the left side. Pause the video here to reconnect the wires according to the detailed image, ending with the part cooling fan in the tool head cover. You can already hear the T300 ABL scan running in the background, and this is very important. After a hot end or nozzle replacement, you need to redo the complete Z offset and bed leveling procedure. I'm not going into details, but it is a bit more difficult on the T300, where we still have to use the paper method. On the SV08, this process is all automated by pressing the Calibrate Z offset button. If you need help with either printer, please watch my earlier videos for detailed guides. Since we replaced the nozzle, it's also recommended to redo the PID tuning for the nozzles, as shown in this video, for example. With a little fine-tuning, both printers produced a relatively good first layer test, and I was ready to prepare the slicer presets for the new nozzle sizes and make dust covers out of PETG for my new AnyCubic Kobra 3. Before we dive into all of that, please take a moment to like this video, subscribe, and enable that notification bell. That's the only way you'll be notified when I post new content about these printers. Thank you if you did. I made a table showing all the settings we'll need to change, but I will also provide these presets in my Cult 3D projects for the two printers. We'll go through these quickly. You can see the SV08 on the right and the T300 on the left. Let's start by adjusting the nozzle size in the extruder section of printer CFG. 0.8 for the SV08, 0.2 for the T300. Click Save and Restart. Now in Orca Slicer, if you already have favorite presets for your printer with the 0.4mm nozzle, I recommend making copies of it, one for the 0.8mm variant for the SV08 and another for the 0.2mm variant for the T300. We only need to adjust the extruder page of the printer settings, the nozzle size and the minimum and maximum layer heights. With the 0.2mm nozzle, we'll be able to go as low as 0.04mm layer height, while with the 0.8mm nozzle, we can go up to 0.56mm thick layers. The good news? You can mostly keep your filament presets as they are. You might want to set no cooling for the first 3 layers, increase part cooling, and half the maximum volumetric speeds for the 0.2mm nozzle, but the larger nozzle can use the 0.4mm filament presets intact. We'll actually test this later in the video. The big changes are in the process presets. Let's go through them with the two nozzle sizes side by side. On the Quality tab, adjust layer heights and line widths to match the new nozzle sizes. On the Supports tab, tweak the interface spacing and consider adjusting the default brim size on the Other tab, but it's really up to you. On the Strength tab, for the 0.2mm nozzle, increase the number of wall loops, but for the 0.8mm nozzle, you cannot really go below 2. Adjust the number of top and bottom shell layers, more for smaller nozzles, fewer for larger nozzles. You may also want to decrease the infill overlap for the smaller nozzle. I have some bad news too. On the Speed tab, we need to slow everything down for both larger and smaller nozzles. These printers seem to be optimized for the 0.4mm nozzle, so they won't print as fast with the other sizes. However, the 0.8mm nozzle will still finish prints faster overall, because it lays down thicker and taller layers even at slightly reduced speeds. To make sure everything worked as expected, I printed a fleet of boats. A regular size 3D Benchy took just over 10 minutes with the double size nozzle, compared to nearly an hour with the half size nozzle. Both prints turned out great, but the difference in detail and resolution is striking. The real show of power came with a half-size 3D Benchy printed with the 0.2mm nozzle and the double-size Benchy with the 0.8mm nozzle. The tiny print shows amazing detail, while the large boat completed in under 45 minutes, impressive considering it has 8 times the volume of the original. For context, a large Benchy like this with a 0.4mm nozzle would take about 90 minutes for the SV08. Of course, I ran out of filament mid-print, and there was a small mishap after switching spools, but the final results were still impressive. 3D Benchies are great, but we need a real test project. Here you can see me 3D scanning this amazing new printer, which I'll cover in an upcoming video. Be sure to subscribe to hear my take on multicolor printing and the AnyCubic Kobra 3 in particular. Both the Kobra 3 and the Creality Ferret Pro 3D scanner were kindly sent by geekbuying.com for testing. If the Ferret Pro looks familiar, it's because you've seen it in action before when we scanned each other with my little nephew. That was a fun way to share tips for capturing organic shapes like heads and faces. Definitely check out that video. This time, the quick scan mode turned the printer into an organic looking shape too. Honestly, the results look like something straight out of a horror movie. But despite the eerie visuals, it's still practical because of how dimensionally accurate these scans are. Thanks to that precision, I was able to design the dust covers without taking a single direct measurement. Having designed similar covers for my SV06 and 7 Plus, I can confidently say this process was much faster and easier. The scans allowed me to create parts that fit perfectly on the very first try with no need for multiple prototypes. For consistency, I ran a quick filament tuning before printing, but there was no need to adjust presets between the 0.4mm and 0.8mm nozzles. Watch this earlier video for my detailed explanation of filament tuning using Orca slicer. And yes, I printed these covers using clear PETG on the SV08 with the newly installed 0.8mm nozzle. I designed all pieces to fit the smaller bed of the Kobra 3 itself, but printing these tall columns on a Core XY using a 0.5mm layer height is the way to go. Needless to say, the new nozzles handled PETG like a champ. Though I haven't had any issues with the original version 1 nozzles either. All 4 parts have strong 1.6mm thick walls, but that's just 2 loops when using a 0.8mm line width. And they printed in just over 3 hours in total. For open frame printers, these dust covers are a must-have in my opinion to protect the exposed and greased rods, rails and wheels. You can find the models I designed for the Kobra 3 and Sovol bed slingers on my Called 3D account. They are a simple upgrade that will save you a ton on maintenance. I think I'm going to keep the 0.2mm nozzle in my T300, turning it into a quick starting precision printer. As for my SV08, I'll restore it with a 0.4mm nozzle, though I might test hardened steel nozzles there in the future if you're interested. Let me know in the comments if that's something you'd like to see. I already have my SV06 Plus set up with a hardened steel 0.6mm big nozzle. That is my printer for large functional parts and flexible filaments. By the way, you might have seen my SV06 Plus in action recently over on Igor's channel, My Tech Fun, in his video about functional prints. Welcome to all the new subscribers coming from there. You can support my endeavors by using the affiliate links below or joining the OG supporters on Ko-fi.com. Check out this playlist for all my SV08 videos and the T300 playlist for all my videos about that printer. With these two or other models, go print 3D. Thank you for staying all the way to the end of this Gergo Print 3D video.